Good morning, Math 30s. We're moving on to lesson 7 in your workbook, which corresponds to page 331. With polynomial functions, what happens is the first half of this chapter is on factoring polynomial expressions. And then starting here in lesson 7 until the end of the chapter, we are going to be graphing polynomial functions and looking at and investigating the graphs of polynomial functions. So what I want to do is I want to do a quick review of a question that we did from lesson 5 on page 317. So you have a little bit of room at the top of your page that you could write it down. I want you to write down this equation that we looked at in lesson 5. So the equation was y is equal to x squared minus 1x minus 6. And what we did is whenever you're given a polynomial, we're able to factor this polynomial. So this is a second degree polynomial, and you learned how to factor second degree polynomials using either inspection or decomposition in Math 10C. And we said, okay, well, what would give us the product of -6 and a sum of -1? And that answer was 2 and -3, okay? So how we would write this in factored form would be y is equal to open bracket x plus 2, that was one of our factors, and the second factor was x minus 3. Okay, so what I want to show you first is whether we enter the expanded form on our calculator or whether we enter the factored form on our calculator, we are going to get the exact same graph. So what I want you to do is take out your graphing calculators, and in y1, let's enter the expanded form. And in y2, let's enter the factored form on our calculators. So I've actually got it in here. So you could just pause the video if you need a minute to enter it. And then what's going to happen is when I hit graph, and if you've changed your calculators, you might want to hit a Zoom 6 standard, so maybe I'll do that. This graph is going to be entered in blue. And this graph, if you watch closely, will be in red. And these, if you factored it correctly, will be identical graphs. So I'm just going to do a Zoom 6 standard. And there was my y1 really quickly right on top if it was y2. So what that shows you, because these are the exact same graph, is a couple of things. That we factored correctly, right? So that's the first thing that this is showing you, because y1 is equal to y2. Okay, so a couple of other things that I just want to talk about the way that these two functions are written. If we are in expanded form, so this form up here, the powerful thing that we could take out of expanded form is our constant at the end is going to be the y-intercept. So we are only able to figure out what the y-intercept is of a graph if we are in expanded form. So for this graph here, the y-intercept is going to be -6. And again, if I quickly look at my calculator to confirm that, this answer here will be -6. How you check that is take your calculators and type in second function, type your trace button, which has calculate above, so second function calculate. You're going to type in number 1. In order to get a y-intercept, you type in number 1 is equal to 0. And the y-intercept is -6. When we are in factored form, we cannot see the y-intercept, right? I can't see that the y-intercept is -6 unless I was to expand it, because 2 times -3 would give us a -6. But what's powerful about the factored form is I'm able to see the zeros. So when you're asked to calculate, like, what are the zeros of the function, what you want to do is you're going to take your two factors and you set them equal to 0. So x plus 2, x minus 3 is equal to 0. Then you take each factor, each individual factor. So one of my factors was x plus 2 is equal to 0. The second factor was x minus 3. That guy's equal to 0. You set each factor equal to 0 and you solve for x. So for this factor, x is equal to -2. For this factor here, or this 0, x is equal to -3. So a couple of things that we just, by equating this to 0, that we just figured out. The zeros of my function are the x-intercepts of the graph. So this x is equal to -2 is an x-intercept. And this guy right up here, x is equal to -3 is an x-intercept. So again, the zeros of my graph, or the zeros of my function, this is a function because I let it equal to 0. So the zeros of my function, what I get when I solve for the zeros of the function are the x-intercepts of the graph. And then we're going to look at our graph and we're going to compare. This is wrong, sorry, that should be 3. If you add 3 to both sides to solve for x, you'd get x is equal to 3. So my x-intercepts, or my zeros of my graph, should be -2 and 3. So we will quickly look at my graph and see if that is correct. So this guy is -2. This guy would be 3. And I'll show you in the first class example how we calculate that, though you would have done this a lot in 20-1, finding the zeros of your graph. Okay, so let's fill in the blanks based off what we just sort of reviewed from lesson 5. So it says fill in the blanks in the following statement regarding the function with the equation y is equal to p of x. So the polynomial equation, which was a second-degree polynomial. So what we're going to write in is the zeros of the function. So the zeros of the function, that produces the x-intercepts of the graph of the function, and we call the roots of the corresponding equation when y is equal to 0. These are all the same number. And those numbers are -2 and 3. So we will often use interchangeably. X-intercepts are the same thing as zeros, but here's how we get the zeros. We have to equate our factors equal to 0. And then we will also call that the roots of the corresponding equation are going to be x is equal to -2 and x is equal to 3. Okay, let's go down to this first class example. So a couple of things. We're given a polynomial function. You should be able, this is an expanded form, right? So realize that this is an expanded form. Expanded form, remember that the constant at the end is going to give us the y-intercept of the graph. So the y-intercept of this graph is going to be 6. So right here, this point, x is 0 and y is 6. So if you're in expanded form, you could always see the y-intercept of a polynomial function. Second thing is, because it's in descending order of x, this is what we would call either a third-degree polynomial or it is a cubic function. Okay. Now, what's powerful about looking at what the degree of the polynomial function is it means that the graph could have up to 3 x-intercepts, is what our graph could have, okay? We'll talk about later on how the graph could actually have less than 3 x-intercepts, but if you have a cubic polynomial function, our graph could have 3 x-intercepts, and sure enough, this graph does have 3 x-intercepts. So what it says is use the graph to state the zeros of the polynomial. So the zeros of the polynomial are the x-intercepts, right? So where does my graph cut the x-axis? At this x-intercept here, and that is going to be -2. So that is a 0 of my graph, okay? Over here is another x-intercept, and that x-intercept is 1. So the second 0 is going to be at 1. And then this x-intercept is 3. So that 0 is going to be 3. If you know the zeros of the graph, you can figure out what the factors of the polynomial are. So for example, I know from this x is equal, or sorry, -2, I know that that's an x-intercept, right? X is equal to -2. If I said, what was the factor that gave me x is equal to -2, what you need to do is you need to bring the -2 back with the x, and the factor that gave you -2 is 0 would be x plus 2. Okay, so same thing. We had here x is equal to 1. That's the 0 of the graph. To figure out what the factor was, you would bring the 1 over there. So to get rid of that 1, we would subtract 1 from both sides. And the second factor would be x minus 1. Lastly, this was an x-intercept. X is equal to 3. What the factor would be, subtract 3 from this side, subtract 3 from this side, and we would get x minus 3 is the third factor. What we're going to do now is we're going to write this polynomial in factored form. So we're going to write p of x, because this is a function, is equal to, and they want this expanded form written in factored form. So how you would do that is each of these factors you need to put in a bracket. X plus 2 is one of my factors, x minus 1 is the second factor, and x minus 3 is the third factor. And if you are in factored form, the nice thing about being in factored form is you should be able to easily look at that and say, okay, that's an x-intercept of minus 2. This is an x-intercept of 1, and this would be an x-intercept or a 0 of 3. What it says for B, and this is going to be the review for Math 20 to make sure that you could find the zeros of any of your functions on your calculator. It says use a graphing calculator to sketch the polynomial in expanded and in factored form to verify the above answers. So remember that your expanded form and your factored form will be the exact same graph if everything is factored correctly. So take out your graphing calculators and let's clear what we had originally in y1, y2. In y1, they want the expanded form, which is x to the power of 3, because it was a cubic function, minus 2x squared, minus 5x plus 6. Okay. In y2, I'm going to enter the exact same polynomial in factored form. So this in factored form should be, open bracket, my first factor was x plus 2. My second factor was x minus 1. And my third factor was x minus 3. I don't have to hit a Zoom 6 window up here because I already did that in the last question. So let's just graph this. Let's pay attention for the blue graph, which will come quickly. And then on top of that will be the red graph. So there's my blue polynomial, my y1, followed by my red y2. These are the exact same graphs. So we did the question correctly. Now, how to see the zeros? There's a couple of different ways we could do this. One method that you could do, which is actually a really handy method, is to look at your table of values. So because these might not be, actually these are going to be all be integral zeros, but I'll show you from your table of values. So second function table, and what we are looking for, actually to make this easier, let's only highlight one of the graphs. So I'm going to go over, scroll and just select that. So what we're doing is we're unselecting this graph here, and it's just going to now graph y1. It's going to graph the blue graph. Okay, so let's go back to the table, second function table. And what we are looking at is whenever you see y is 0, that is going to be the 0 of your graph. And the corresponding x would be your x-intercept. So these are my zeros right here. And there should be one more. There's the third one. So that first 0 was -2. The second 0 was 1, and the third 0 was 3. The other way that you could do this on your calculator, so let's say I said to you, okay, I want everybody to find what this 0 is. In order to do that, if you didn't want to use your table, but I find the table's really efficient if it's integral zeros. So integral zeros are just like -1, -2, -3, 0, 1, 2, 3. So no decimals, essentially. So let's say I said, let's find this using our graphing calculator, but not using the table. Type in second function, hit your calculate button, and we're going to be looking for a 0, which is number 2. Bring your cursor close to the 0 that you're looking for, which is right about there. And you have to hit your left cursor first. So I'm going to hit my left cursor once or twice. Hit enter. Now go back to the 0, and then it says hit your right cursor. So I'm going to hit my right cursor a couple times, hit enter. And then guess just means you hit enter again, and that 0 is -2. So just to double check that you understand that, can everybody, you can pause the video if you need, but I want you to find this 0 here. So second function, calculate number 2. Okay, I'm close to the 0. I always go left of the 0 first, which would be there. and I go back to my 0, and it wants me to go now right of the 0, so I'm going to go above it by hitting the right button, enter. Guess means enter again. That 0, this is a 0, is at x is equal to 3. Okay. So we are able to verify. And remember, factored form, expanded form shows us the y-intercept of the graph. There's one more class example that we're going to do, and then I will give you your homework for this lesson. Okay, class example 2 is on page 332, and it says, use a graphing calculator to sketch the graph of this polynomial function. So before we do this, let's do a couple of things. So this is an expanded form, which is always nice, because I'm going to get my y-intercept. So the y-intercept of this graph is equal to -10. So when we punch this expanded form into our graphing calculators, we're going to verify that the y-intercept is -10. The degree of this function, this is a third degree polynomial. And again, what that means is that it's written in descending order of x. So I look at the x with the biggest power to give me my degree. This is going to be a cubic function. And what a degree 3 means, or third degree, it means the graph could have up to a maximum of 3 x-intercepts. And I believe this graph will have 3 x-intercepts. The last thing, and this is going to be in the next lesson, but this guy here is a -1. So the leading coefficient of this function, what leads the group, is it's got a negative leading coefficient. So we're going to say there's a negative lead coefficient. And then what you're going to see in the next lesson is third degree polynomials that have a positive leading coefficient. So the one we did on the last page, they look something like this. And then this graph, it's going to have a negative leading coefficient. It is going to look more like this. Okay, so that's going to be the next lesson where we'll discuss that. But just know for now that this is a negative leading coefficient. Okay, use the graph to state the x-intercepts. So let's punch this function into our calculator in expanded form because we don't know what the factored form is yet. So go to y is equal to, clear your functions, and let's type in our negative leading coefficient, so that negative there. We're going to type in an x cubed plus 4x squared plus 7x minus 10. Okay, from here, let's graph this. And what I want to do is I want to be able to see this graph a little bit more. So this is a 10 by 10 window. So it goes x is 10, y is 10. Let's go up to an x max of maybe 20 and a y max of -20, or sorry, y min of -20. So go to window on your calculator and let's change our window. So let's change our y minimum to -20 and our y maximum to 20. And then what I do for my scale factor, this is like each hatch mark is going up by 1. I'm going to change it. If my maximum is 20, I'm going to enter that less a 0. So I'm going to enter it, my scale factor is each hatch mark to go up by 2. So when I graph this, there's my graph that I could see a bit better. So these are going to be integral zeros. So that's going to be -2, 1, and 5, but let's double check on our calculator. So again, easiest way to do this, we know we have 3 zeros. So I should see 3 zeros on my table. 1, 2, 3. If you do not see 3 zeros, what that means is one of the zeros will be a decimal, and you'll have to do your second function calculate a 0 left bound, right bound. But if we can find our 3 zeros, this is the most efficient way to do this. So my zeros, or my x-intercepts, are -2, are 1, and 5. So let's record that. The x-intercepts of this graph are, use the graph to state the x-intercepts. Okay, so x is equal to, it was -2, 1 was an x-intercept, and 5 was an x-intercept. So -2, 1, and 5. These are all going to be x-intercepts. So -2, 1, and 5. I know without even checking my calculator that the y-intercept is going to be at -10, right? But let's confirm that on our calculator. So go to your calculators, your graph. This guy, remember I changed the scale to each hatch mark is 2. So -2, 4, 6, 8, 10. But how you're going to check more accurately is you're going to go to second function, calculate. You're going to calculate a value when x is 0. There's my y-intercept at -10. My arm starts here. It's going to go down, up, and down. So let's draw this. So we're starting in quadrant 2. Okay, from here, what I want you to do is I want you to put an arrowhead, which shows that this graph is going to continue forever in that direction and forever in this direction. And then I'm going to label this at 10, label that at -2, that's a 1, and that's a 5. Okay, write the polynomial in factored form. So again, our x-intercepts, they were -2, they were 1, and they were 5. To get the factored form, you need to bring that -2 over here, so add 2 to both sides, and you're going to get x plus 2. That is one of your factors that gave you the 0 of -2. To get a 1, subtract 1, and the factor would be x minus 1. Last, to get x is equal to 5, let's subtract 5, and we would get x minus 5. It gives us a 0 of 5. Write the polynomial in factored form. I must start this with p of x is equal to, and then my polynomial. If you were to type this into y2, and if you wanted, you could pause the video and do that, the graph would go right on top of the expanded graph because it's factored correctly. Okay, oh, no, it would not, because I am missing something. So let me actually show you. Right now, it would not. Let me show you why. So this is why it's always good to check. Let's say you did, and you're like, I'm going to just double check this. So we had an x plus 2, and we had an x minus 1, and we have an x minus 5. So you know these are the zeros, right? And you're like, okay, this is the expanded form, this is the factored form, let's check if it is the same. And it's not. So what did I do incorrectly? What you have to say is the leading coefficient here was negative. So in front of these 3 factors, I must put a negative. If your leading coefficient is negative, you must put a negative in front of those factors. And now when I go to my calculator, I'm going to go back here and I'm going to go to second insert. So insert's right here. I'm going to insert that negative, and now it should be identical. There we go. Okay, so just make sure that you're doing that for the homework questions and that you're verifying that you did the answers correctly. Okay, you have to be able to fill things like this or discuss things like this in talking about your graph. So circle the correct alternative. The left arm of the graph, this is the left arm of my graph. This left arm is rising if I kept letting it go on and on. This is the right arm of my graph. This guy is falling. The degree of this polynomial, it is a third degree polynomial, so it is an odd polynomial, and the leading coefficient of this polynomial is negative. There is a negative in front of the expanded form, therefore there must be a negative in front of the factored form. All right, that concludes this lesson. There's 3 questions in your homework. I don't want you to do all of them. For number 1, it looks like a lot, but you're essentially not doing A and B. And then for number 2, A, B, C, and then number 3, I want you to do. And that concludes this lesson.